So, solve by completing the square. So the idea of completing a square is you want to use the fact that we know that a perfect square trinomial has two of the exact same factors. So, we want to make this into a perfect square trinomial. First thing you do is you move this to the other side. So I'm going to add 5 on both sides. Now, I have x squared minus 4x equals 5. So, if I want to solve using completing the square, literally I want to know what number do I have to add on both sides, so that way the left side will be a perfect square trinomial. Remember, a perfect square trinomial has two of the exact same factors. So, when you add it, okay, it's half of b, and then you square it, and that's what you add. What is half of negative 4?
2.
Negative 2. And if you square negative 2, you get 4. Okay, so I'm going to add 4 on both sides. This way, on the left side, I can rewrite my trinomial as x minus 2 times x minus 2, and that's going to equal 9. So, yes. What is negative 2 times negative 2? 4. Half of the middle, so half of negative 4 is negative 2, and then squared is our c value. That's what we're going to be adding.
Oh, so you're basically just splitting it.
So I'm moving my 5 over, so that way I could make the left side a perfect square trinomial.
Thing where you what multiplies the 4 but adds them.
How did you get x minus 2 and x minus 2 then? Because like what happens to the negative 4x?
Well, if you FOIL x minus 2 times x minus 2, you get x squared minus 4x plus 4. So this part right here is a perfect square trinomial.
Just take everything and divide it by 2. Ignore the 4.
So you take half of this middle number, right? If I divide it by 2, half of it will be negative 2. And then if you square it, that's what your c value should be. Half of your middle number, and then squared is what you're going to be adding on both sides. So maybe at the end we can do another example of completing the square. So I showed an intermediate step, meaning ideally you wouldn't use this step right here. Ideally you would go straight to x minus 2 squared equals 9, right? Because we would like to use the fact that, square root has a plus and minus root. Right? If you take the square root, you have a plus or minus root. Yes, question?
Wait, so after that step with the x squared minus 4 plus 1, don't you do like what multiplies the 4 that adds the negative 4?
No. So I used the fact, I wanted to know what to add to both sides. That way this left side would be a perfect square trinomial, meaning two of the exact same factor.
So that's basically the first step when you do negative 4 divided by 2.
Yeah.
Oh,
Because I'm trying to figure out what to put in my blanks. What magic number can I add to both sides? I have to add it to both sides, that way it's equal. So really the first step is moving this 5 over. But once we do that, then it's okay, we got to make the left side be a perfect square trinomial, so I can write it as two of the same factors. So I need to solve for x. X is inside, x minus 2 squared. So if I square root both sides, right, square root both sides, the square and the square root go away, and I'm left with x minus 2 equals plus or minus 3. We are taking the square, so you have to include plus or minus. If I just asked, what is the square root of 9? I give you the square root. You would say the positive 3. If you're taking the square root because you're trying to solve for x, you have to include both the plus and minus.
Do you have to split it up and do plus or minus 2 and plus or minus?
So my two solutions are going to be x minus 2 equals 3 and x minus 2 equals negative 3, because I've taken both things into account. X minus 2 is going to equal positive 3 and x minus 2 is going to equal negative 3. That's why it's equal to plus or minus 3. So add 2 to both sides. I see x equals 5. Add 2 to both sides. X equals negative 1. So these are our two answers.
On the test, are you going to give us anything that isn't a perfect square like this?
I could. I did that in did that on the notes. So. So I did that in the notes. I showed you how to deal with one that's not a perfect square on the right side. Yep, we can. Number 12, solve using the quadratic formula. Are we good to move on? Wait a sec, so you're not writing too fast. So I give you the quadratic formula. It's not something you have to necessarily memorize. You have it memorized, but I'll give it to you. Because I'm not trying to test your memory. I'm trying to test, can you actually like apply the knowledge?
Can we do this one though? Because
Number 12? Yeah, we're going through all the problems. I'm just giving people time to write down the previous thing because I see people are frantically still writing. So I'm trying to set up the problem to have you guys try it, but not rush you. Okay, so I give you the quadratic formula. Negative b plus or minus square root b squared minus 2ac all over 2a. So quadratic formula, I see a is 3, b negative 2, and c equals 5. What? It is, sorry. I have my 2a at the bottom, 4ac. B squared minus 4ac. I don't think that's up there, is it? I think it's in another room. There's like a whole thing up for it. Okay. Alright, so I have my numbers. I can just plug in. X equals negative of negative 2 plus or minus negative 2 squared minus 4 times 3 times 5 all over 2 times 3. So this is going to equal 2 plus or minus, let's see, negative 2 squared is 4. Let's see, negative 4 times 3 is negative 12. Negative 12 times 50 is negative 60. What did I say?
It's 50.
Oh, yeah, negative 12 times 5 is negative 60.
So we wouldn't do like 3 times 5 first.
You could. Do you know what 15 times 4 is?
Isn't that like 56?
60. 60. I did the easier one first because 12 times 5 is something you know. Over 6.
So we could go in the order just like 1, 2,
Well,
3.
okay, this is just multiplying. Since I'm not using a calculator, I'm going through and trying just to use your brain for the math. You will have a calculator on the whole test. So you could punch in and say, okay, 3 times 4 times 5. Yeah. But you know 4 times 3 is 12, and 12 times 5 is one of the math facts that you're required to know in middle school. So 12 times 5 is 60. Alright, this is 2 plus or minus root negative 56 over 6. Okay, so am I going to have, how many real solutions will I have? None, because I have a negative under my root. But I would like to simplify this, because this is like 2 steps away from being correct.
What's 56 divided by 5?
So we're on the right track, right? So a bunch of us, let's figure out what are the factors of 56. 56 is 8 and 7. Let's see, factors of 8, 4, and 2. So I'd like to have like a perfect square. So I could rewrite root 56. Just find a different spot. Don't sit by my stuff. Talia, just find a different spot. Don't sit where my stuff is. Yeah. Okay, so root 56, I can write this as root 4 times root 14. Because 4 times, what's 2 times 7? 14. So I can write root 56 as root 4 times root 14.
Could we do this like really easier?
Yeah, we
Make it
break
into
down
a
the 4.
2.
Right, because root 4 is 2. That's the whole idea. I'm trying to pull out a perfect square. So I can rewrite this as 2 plus or minus 2i root 14 all over 6. Where did the I come from? Because it's a negative,
Came from
exactly.
your imagination.
But what about, can't we just factor into like 9 and like what's
54 is 9 times 6. So, right. So we pulled out a perfect square. Notice that all of these factors have a 2 in them. Right? So 2, 2, and 6. I can divide everything by 2. So I'll get 1 plus or minus I root 14 over 3. And that would be your whole answer.
I don't understand why you don't divide what's inside the.
Divide, what do you mean?
I don't understand why you don't divide what's inside the.
Because it's root 14 is being multiplied by 2i. All of them have a factor of 2.
How'd you do the one?
Oh.
How'd I do what? So all of the things in pink that I crossed out have a factor of 2 in them. So if I would have pulled out a factor of 2, on top I would have 1 plus or minus 1 times I times root 14. And if I pull out a factor of 2 on bottom, I get 3. So that's how I can just cross them out. It's doing the same thing as what I wrote a little bit to the left with the navy and the pink. So, right, so this page, right, there's one solved by factoring, one solved by cleaning the square, one solved by using quadratic formula. There you go. That's what 10, 11, 12 is. You have to know how to do these methods. So I give you the quadratic equation. All right, number 13. Yeah, sorry, I give you the quadratic formula. Yeah. Technically, it's a formula. Yeah. Okay, let's go on. Number 13, solve using any method. So, this is where you will shoot yourself in the foot if you go through and do quadratic every time. What is the order? First thing you always check for? Greatest common factor. Is there a greatest common factor?
10.
Yes. What is the greatest common factor?
4.
4. So pull out a 4. I'll have x squared plus x minus 6. Do you have to? No. But I'm telling you right now, if you use quadratic formula for every one, you're going to run out of time. You'll run out of time.
Where you like
What?
times the 4 to 10.
So I'm factoring it out. You want to pull out a common factor. What's wrong?
Can't you just like divide everything by 4?
That's what we did. Factoring out of 4 is like dividing everything by 4.
X to the second plus x
Plus minus 6.
equals 0.
Yeah.
Like, but shouldn't we just get rid of the 4?
Well, it's not going to affect our answer. So if you want, divide both sides by 4 here.
Like divide 4x to the second, divide 4x.
Right, and I still get the same thing. Because it doesn't affect our answer at the end. So if you divide by 4, I mean, you're going to get the same thing that we do here. It's just, I'm leaving it in fully factored form. The 4 is not going to do anything. So in like a minute, you'll see like, oh, okay, that's why it doesn't matter.
Can I explain this to you, like, really, like, this is how you do it. If you move the 4x to the other side, and then...
Who are you explaining this to, me or someone else? No, no, it's fine. Like, I'm going to get it in like a minute, okay?
Okay.
So what adds to 1 multiplies to negative 6? Plus 3 minus 2. Okay, so if I have a positive 3 and a negative 2, multiply them, I get negative 6. Add them, I get 1. Perfect. So I have x plus 3, and I have x minus 2, and I have it fully factored. So if we set each factor equal to 0, there's only 2 factors with x. So I'm only going to be setting x plus 3 equal to 0 and x minus 2 equal to 0. Like the 4 doesn't do anything. Like, because I can't set 4 equal to 0. That's not true. So it's not going to give me a solution. So
Adds to 1 multiplies to 6.
yes,
Okay.
adds to 1 multiplies to negative 6. So if I set each of these equal to 0, I see x equals negative 3 and x equals 2. That's the whole problem. So the 4, if I set each factor equals 0, 4 equal to 0, no, that's not true. It doesn't give me a solution. So so this is what Isabella was talking about. Okay, divide every single term by 4. I get the exact same answer. Whether I have this 4 over here, beginning or end. What? No, the whole point was we factored out the 4 at the beginning. That's why it's here.
At the beginning, can't you multiply 4 to 0? Will you get 0?
I can't. If you multiply the 0 by 4, you have to multiply all the left side by 4 as well. If you
There's a thing where you like multiply the first number.
So the first number with this one right here. But that's the third thing we do. We have to go on the hierarchy. First thing we always check for is greatest common factor. Then you check if it's a special case, perfect square, or difference of squares, perfect square trinomial. Then you try factoring. So if this was, let's say this middle was like a 3 instead, I can't pull out a 4. There's no common factor. It's not a special case. I would have to then do it that method. But because all of these were factors of 4, I can pull it out. So this 4, I could have divided 4 right here as well after I pulled it out. 4 over 4 is 1. 0 over 4 is just 0. Like, it doesn't matter if I get rid of it or the fact that down here I set each factor equal to 0. Like 4 equals 0. This doesn't give me an answer, so that's why it doesn't matter. You could have divided, sure, by the first step. It doesn't change the answer at all. What you have to be careful of is, like, you have to pull it out. One way or another, you have to get rid of, like, you have to pull out the 4, so that way you get your x squared plus x minus 6, yes?
What do you do? Can you explain again how you got the x plus 3 and x minus 2?
Yes. So, we looked in the middle. What adds to 1 multiplies to negative 6. So, we said positive 3, negative 2. You add them, you get 1. You multiply them, you get negative 6. So, those are our two solutions. And that took not too long. Okay, let's try this next one. X squared plus 5x plus 6. If you immediately go to a quadratic equation, it's not going to help you. It shouldn't be solved that way. Because first, we look, is there a common factor for number 14? No. Is this a special case? Is it a difference of squares? No. Special, let's see, perfect square trinomial, where it's like half the middle squared is our last number? No. So we can try factoring. Do we know two numbers that will add to 5 and multiply to 6?
Yes.
Yeah.
X minus 1 and x plus 6.
Well, they have to multiply to positive 6.
Oh, wait, positive.
5 and 1.
Wait, you don't,
5 times 1 is
you don't
5.
subtract the negative first.
3 and 2.
3 and 2, right? If you add 3 and 2, you get 5. If you multiply 3 and 2, you get 6.
You don't subtract the 6 to 0.
No, because that's completing the square. If you want to solve using, yeah. So you have x plus 2 times x plus 3 is 0. Set each factor equal to 2. I'm sorry, to 0. Set each factor equal to 0. X equals negative 2 and x equals negative 3. Right, imagine if you use quadratic formula, you would still be working on this problem. Still be working. Still be going through the steps. So I gave you 2 easy problems right in a row, secretly. Number 13, you had to do Gray's common factor, then factor. This one was just factoring. I could give you one that, I don't know, you have to solve using completing the square. But you don't have to. See, this whole page, 13, 14, 15, you solve using any method.
15, you have to
But you,
multiply
like, for
with
some
4,
reason
right?
you can't.
Right, so let's get to 15. Huh? Let's go to 15. All right, if you haven't already, you can go ahead and put your phone over in the red.
I'm not on my phone. I'm just
It's fine. I'm just saying there's like only 9 phones over there. There's 11 of you. So go ahead, just put it over there. You still have like 24 minutes. All right, number 15. Let's look. Go through the steps. Is there a Gray's common factor I can pull out?
No.
No. Is this a special case? Is this a difference of squares? No, because difference of squares only has 2 numbers. And this has 3 terms,
But
right?
you
2
did
terms.
The other one,
Is this-
square, isn't it?
I didn't. I did a perfect square trinomial. Is this a perfect square trinomial? No, because if I look at this number in the middle, 3 divided by 2, well, you only can have even numbers in the middle for a perfect square trinomial. Okay, so we got to try factor. We have a coefficient other than 1. So this is what Talia was talking about. First step, we take the 4, multiply by our c. We rewrite the whole thing. Rewrite the whole thing without the coefficient of x squared with our new c. So we're looking for what adds to negative 3 and multiplies to negative 20. Do you know any numbers that add to negative 3 and multiply to negative 20? Let's see. Let's find our factors. Maybe like 1, negative 10. No. Negative 1,
But that
10.
wouldn't even equal to
Yeah,
20.
5 and 2.
That wouldn't multiply
Oh,
to
wait.
20.
So it's negative 9.
So
Oh,
now-
sorry. I meant 2.
How did you just multiply the 4 by the 5?
So this is our method for factoring with coefficients in front of x squared other than 1. Notice the 4 I circled, that's not a coefficient of 1 in front of x squared.
So with any coefficient that isn't 1 in front of x squared, you multiply by the c?
Yes, but only if you've already checked that it's not you can't pull out a Gray's common factor, and it's not a special case.
What about 5 and 4?
Let's see.
Doesn't add to -3.
5, negative 4, negative 5, 4. Let's see. So this is negative 1, this is 1. None of these are equal to negative 3. So, looks like we are on our fourth, our nuclear option. We have to use quadratic formula here. We have to. We've gone through and we've tried solving other ways.
Wait, but we haven't done it normally yet.
We
Oh, no, wait,
have.
we have to-
This is the normal way of doing it with coefficients other than 1 in front of x squared.
What's the normal way called?
Factor, like normally factoring, like how we did number 14.
Yeah.
That's what he was talking about, but this is the normal way for coefficients other than 1 in front of x squared. Question? No? Okay. So, this is proving there's no factors, so like this isn't going to work. We have to use quadratic formula. Ay, ay, ay.
Could you do that for the fourth one? I mean,
Fourth.
13, where you like,
The quadratic formula?
when you like, yeah.
The coefficient? Are you, okay, let me be clear. Are you asking if we could have took the number and multiplied by c?
the 13.
No. Well, I mean, you could have, but why? The whole point is to go through an order. First, you check Gray's common factor. Then, special cases. Then factoring. So that's why we went through and made sure there's no common factors. This is not a special case, and then we are going to factor using this method. You only want to go to this method after you've checked for greatest common factors.
So we're not using that one.
We're not using this method for number 13. You could, and it would take you a long time, and you would find the same answer as we do, but it's going to take you like 4 times the amount of time. You should go in order. There's a hierarchy. I'm not up here squawking for the fun of it. Like, I'm trying to help you see. First, you check for greatest common factor. Then your special cases. Then you try factoring as normal, and then you do quadratic equation. There is a hierarchy. That's the way you should go through it. Yes, Ruby?
For quadratic, whatever, would make a and c 4 negative 5.
Yeah, I'm going to go back to the way it was originally. Because this whole method of moving it around, we do go back and put that, put the coefficient back in. We put the 4 back in.
Would we get this thing now too? If we did it with
No,
Yeah.
no. So A is 4. What the heck? A is 4. B is negative 3. C is negative 5. So, we have negative b, x equals negative b plus or minus square root b squared minus 4ac all over 2a. So this is negative of negative 3 plus or minus negative 3 squared minus 4 times a times negative 5 all over 2 times 4. So this is 3 plus or minus square root. Negative 3 squared is 9. Let's see. Negative 4 and negative 5 are 20. 20 times 4 is 80, so plus 80. And you will have your calculator, so you could show, you could, instead of doing negative 4 times negative 5 in your head, type that in and you'll get the same intermediate step. And the reason I'm going like term by term, like I squared this, I simplified this part, and I went through and I did like this multiplication. So I'm trying to go like methodically showing work. Because if you just plug it into your calculator and you get the wrong answer, you don't get points. I'm trying to help you by giving points for the partial work. You should show the partial work. That way if you accidentally do a little tippy type, whatever on your calculator, I can still give you as many points as possible. Okay, Let's keep going. So I have 3 plus or minus root 89 over 8. Can I simplify this at all?
No, this is the wrong number.
89 is prime. Is that what you said? Hey, yeah, that was good. That was a vocab word, prime. There's no factors for 89 other than 1 and 89. I cannot simplify this at all. I can't cross out anything. This is it.
Nothing multiplies to 89.
Nope, besides 1 and 89. It's prime. No other factors.
So that's our final.
That's it. That's our answer. So what you could say, okay, well, x equals 3 plus root 89 over 8. This is if you don't like writing plus or minus. And x equals 3 minus root 89 all over 8.
So we're allowed to write this.
But you can write plus or minus, yeah. Just once again, pound it into your brain what plus or minus means. Woo, okay, getting close. Number 16. My hint to you for number 16 is go in reverse. It's literally going in reverse. Instead of what we've been doing on this page, like number 14, where we had a quadratic, factored it, set each factor equals 0, and then we had what x equals. Number 16, we have what x equals, and then we got to go back and make a quadratic from it. So if these are my two roots, that means one of these are my two roots, right? X equals 3 and x equals negative 5. Ideally, I would like to put these in like factor form. So if I subtract 3 from both sides, I would like to make it so I have like x minus 3 equals 0. Add 5 on both sides. I have x plus 5 equals 0. And then notice I have two factors. Because whenever, like if you look up at number 13 or 14, whenever you have two factors being multiplied and it's equal to 0, you set each factor equals 0. Whose phone is that? You want to move it down to another one? Just don't put it in one that's broken. That's all you got to do. Find one that's not broken. Shove it down. It's all good. It's fine. Who cares? Just put it in there. Plastic will stretch. Okay. All right, so I have two factors. This is one of my factors. This is my other. And you're going to multiply them together.
You always multiply?
Foil.
Foil them. Woo! Foil. X squared minus 3x plus 5 minus 15. So I set it equal to 0 because I was trying to find one of the factors. Remember, if I have a quadratic and I write it in factored form, like number 14, I set each factor equal to 0. Well, since x minus 3 is set equal to 0, I know that's one of my factors. So I'm going to set my two factors, multiply them together. So this is going to be x squared plus 2x minus 15. And this is our answer, because we're trying to write a quadratic equation in standard form. Well, remember, standard form is ax squared plus bx plus c. This is standard form. This is in standard form. What? No. If you look at the practice test, all I do is basically change numbers, and that's your exact test. So you have to know how to do all of these problems.
Is this always going to be how you like do this? Like when you ask us to.
Yes.
Like,
You set, I give you the roots, you say, oh, x equals those roots, you move them over, and you have the factors and multiply them. This is literally, you're going in reverse. Because look at this problem versus like number 14. So imagine number 14, I said, oh, the roots are negative 2 and negative 3. So you move those over so they're with x, so you have x plus 2 and x plus 3 equals 0, and then you take these two factors, multiply them together, and then you get your quadratic. So that's what I mean when I say go in reverse. You're like going from this step up. Okay. Lastly, simplify each expression completely. So this one, we also have to FOIL. Oh my goodness, FOIL. First, 6. The O, FOIL of O, outer, plus 3i. I of inner, plus 2i. L for FOIL, L last, so plus I squared. So if I combine these two, I have 5i. 6 plus 5i. What is I squared equal to?
1.
I squared is equal to negative 1. So I'll be subtracting 1, right? Because that's what I squared is negative 1. 6 minus 1, so I have 5 plus 5i, and that is the answer. That's it. Dunzo. Just have to FOIL and recognize I squared is equal to negative 1. This is not something I give you. You have to know I squared is negative 1.
Ooh, I5 is 1.
I5? What? 5i? I squared is negative 1. Hmm? I don't know. What's, yes?
So like for every I, like if it's like squared to like 2 or like 3, it's like the pattern is like I, negative 1, negative I, negative 1.
So number 19, I'm going to go over that.
Oh, wait.
Yeah.
I5.
I to the 5th power?
Yeah, how would
Yes, but this is not I to the 5th power. This is 5i. This is not I to the 5th. That's different.
So if it was like
Versus 5i.
that, you can just put I.
Yes. I'm going to go over the pattern on number 19. I'll go over the pattern for the i's. Number 18, what do we do here? No, because it's subtracting, so we're going to distribute 7i minus 5 minus 4i plus 1. We just have to combine like terms. 3i minus 4. The negative sign in between means we're subtracting these two terms. So I distribute the negative and then I'll like add them together. Then I'll combine like terms. If there was no negative sign here, and I just have the parentheses to parentheses like I did number 17, then you'd have to FOIL. But number 18, there's a subtraction sign in between. Cool. All right. Questions before we go to 19?
Wait.
Questions for 19?
Ooh, can I check my laptop
No.
to see which class I have next?
No, we still have 10 minutes of class. You can wait till 2 minutes are left. Okay, I to the 39.
Okay,
So there's a pattern. 1, 2, 3, 4.
So
Let me
if, like,
move over.
divisible by like 3, for example, this, that would be the third one, right?
One moment. So I'm making myself a little table. I to the first power, I. I squared, negative 1. I to the third power, negative I. And I to the fourth, 1. Okay, so if I have, let's see, 39. So I want to take 39 and divide by 4. How many times can 4 go into 39?
All of them.
9, right? 9 times 4 is 36. 36. And there's 3 remainder. So 3 remainder. 3 remainder. 3 remainder. What? If there's no remainder, it's 1.
Why do you
Because
take
four.
4?
Because there's 4 options what it can be. If I have 1 remainder, yes.
Yes.
And if it doesn't work? Oh, no,
Then it'll always work.
So if I had like, since this is I to the 36th power, right? Because it goes evenly. Remainder 4 is the same as like a remainder of 0. It's like remainder 1, remainder 2, remainder 3. The last column is it just goes evenly.
Did you just like
36, so this is I to the 37, I to the 38, I to the 39th, it's right here. Oops, I to the 40th would be the last column.
so I to the 36th would be
To the last column would just be 1.
You have to show that one.
like
Hold on. I can't answer 2 questions at once, you and then you.
This was probably like coincidental, but
That's
I was
fine.
like, oh, like 39 is divisible by 3, so I just did.
Yeah, that's coincidental. It has to be divisible by 4.
But
You have to divide by 4.
Also, like, what if you give us like I like the 5th or something?
The 5th, that should be an easy one.
So
Divide by 5 by 4. It goes in 1 time. How many remainder? 1. I to the 5th is I.
So you
Ready?
have
I to the
I to the
second,
first, I to the second, I to the third, I to the fourth, I to the fifth, I to the sixth, to the seventh, to the eighth, to the ninth, to the 10th, to the 11th, to the 12th. I to the 60th, I to the 64th, I to the 68th. Anything is divisible by 4.
you have to
And
show
it
that
goes
one.
by 3, and
But that's what I said, that's
I want to see like this. It's
Oh, no,
fine.
wait, that's not
But
right.
I said the answer.
Okay, so
Divisible by
hold on. He has a good question, and I'll make sure to answer it so everyone can hear. So he said, like, how do you show your work? I mean, this is fine. You could show this, and you could list this out.
So what's the final answer?
Well, what did I highlight? What is the answer?
I.
Negative I. So your calculator will do this for you, which is why I want you to show work. I'm letting you use your calculator, so that means you have to show your work. Every problem, you must show your work. Yes, you always divide by 4, because there's 4 options. Okay, question? Well, I'm not going to give you one that's 39. I'll give you one that's harder. So you can't just count to 39, huh?
What if we like do a law calculator?
What do you mean?
Divide all of them by like 4, 3, or like whatever it is.
So you have to divide by 4, and then you see how many remainder you have. What are you doing?
Oh wait,
Sit
4
down. Sit down.
Away things in
is
the
highest
garbo.
number you
Okay.
can divide by.
Not that.
Huh?
You would know it.
4. 4 is what you divide by, and how many remainder you have is which column it goes into.
You wouldn't divide by like 4.
No, you always divide by 4, because there's 4 options. You divide by 4. How many remainder you have is which column you go to. Okay, last question. Write an equation vertex form for the parabola with vertex 1, 3, containing the point 2, 4. So vertex form I give you. Y equals a times x minus h squared plus k. I give you this. I give you this equation. I gave it to you on your quiz. I'll give it to you on your test. So, vertex, it literally tells you vertex. So this means your h is 1 and your k is 3. And I have a random point, 2, 4. So ideally, I would like to, all right, I have my vertex, so I could write this as y equals a times x minus 1 squared plus 3. The only problem is, I don't know what this a is. I have to solve for a. That's why I gave you this other point. So we could plug this in for y and x, and then go through and solve for what a would be. So this, I'm going to use, my x is going to be 2, my y will be 4. So if I plug this in, I should be able to solve for a. Let's see, 2 minus 1 is 1. 1 squared is a plus 3. Subtract 3. So I see a is 1. Okay, cool. So now I know what to put in. So I plug that back in up here. And if y equals, if it's just 1, I can just leave it alone. I don't have to write it.
Yeah.
Okay, so that is it. So remember, I'm going to give you this thing, which is vertex form. I'll give you the vertex formula, negative b over 2a. I'll give you quadratic.
There's nothing to solve after.
We do another.
No, because it says write an equation in vertex form. Write an equation in vertex form. Okay, so I'll end the screencast here.